Hello, Namaste. Welcome to my presentation titled ChemCollective, a potential virtual lab for chemistry practical. I am Dr. Ram Gopal, Chemistry Faculty, Collegiate Education, Andhra Pradesh. The objective of today's presentation is introduction of virtual labs to undergraduate students. You're, you're well aware that undergraduate syllabus includes titometric analysis in the third and fourth semesters. This presentation is an attempt to demonstrate the usefulness of ChemCollective interface as a virtual lab. What is a virtual lab? A lab where a student can perform an experiment on a computer. The ChemCollective application or interface provides a virtual lab. So a student, by using his computer, can do his laboratory experiment. That is a virtual lab. Now, what is the relevance of virtual lab? Why we are talking about virtual lab so extensively today? You all know that all walks of life have been severely affected by COVID-19 pandemic. Education is no exception. It has been an enormously challenging task for education field. College hostels are yet to open, fearing second wave. Still, a lot of students are away from classrooms. COVID-19 era has seen an exponential rise in digital learning through online mode. Now, what is the reach of virtual lab? High secondary, intermediate, UG and even PG level experiments are available on the ChemCollective application, especially with regard to physical chemistry and titometric analysis. You can explore these experimental techniques through ChemCollective Virtual Lab. Although a physical lab has no replacement, the inevitable situations that are unwarranted have made a supposedly pre-laboratory platform, that is a virtual lab, to an all-in-all experience. For now, virtual is reality. Now, is a virtual lab self-sufficient? As of now, if you once visit the ChemCollective virtual lab, you can see the chemical repository is very limited. But you need not lose your hope. There is hope. And I believe it will be demonstrated during this presentation. Now, if the repository is limited, is it customizable? Will be the next question. Yes, it is absolutely customizable. It is possible to modify an existing activity or add new activity on ChemCollective Virtual Lab. Only thing to be done is to collaborate with the ChemCollective Virtual Lab people. A link is provided in the teacher menu, and once you visit this, you'll know how to collaborate with the ChemCollective Virtual Lab. Coming to our UG syllabus, Paper 3, a practical Paper 3, includes titometric analysis for 25 marks, and this is at the end of semester 3. A few of the questions, if you go through them: determination of iron 2 using potassium permanganate with oxalic acid as primary standard, and determination of copper 2 using sodium thiosulfide with potassium dichromate as primary standard. Let us visit ChemCollective version 2.1.0 for experiencing the application. These are some of the links. I shall share them after I demonstrate an experiment to you. Open the VLab application folder and then double click on VLab application file. The virtual lab interface will open. Go to the view menu, select themes and then presentations. You have stockroom explorer, workbench and solution info as 3 panels. So this is the first panel, and to the left it is stockroom explorer. You have distilled water there and you select it and go to the workbench and click on the first tool. You will be placing distilled water and you can see the content. 3000 ml of distilled water is contained in the container, and then stock solutions. You can also see strong acids in the stockroom explorer, sulfuric acid, HCl, HBr, etc., and weak acids, acetic acid, hydrofluoric acid, etc. Scroll down. Conjugate acids like ammonium chloride, etc. Strong bases, of course, sodium hydroxide is exclusively there with different concentrations, different stocks. And then conjugate bases. You also have indicators: methyl orange, methyl red, phenolphthalein, bromocresol green, and then solid. You have sodium chloride. Now, our experiment requires oxalic acid as solid. Hence, I'll be renaming the sodium chloride as oxalic acid. This is only demo purpose. Our work as faculty members is to collaborate with the virtual labs and develop or customize the application so that our oxalic acid, potassium permanganate for estimation of iron 2 also exists. Now what I am doing in the meanwhile is I am placing glassware onto the workbench. I have already taken a beaker and also Erlenmeyer flask, and then clicking on glassware tool, I have taken 10 ml graduated cylinder, which is a measuring jar, and again clicking on glassware and collecting 10 ml pipette. Then 100 ml volumetric flask is placed on the workbench. 50 ml burette is placed on the workbench. And the last one among glassware is foam cup. Of course, we don't require it, hence I am removing it from the workbench. I have removed it. And one more menu is there on the workbench, which of course is a tool menu. You have Bunsen burner, and then weighing scale or weighing machine, and then you also have a weighing board. Of course, this is not required for this experiment, hence I am removing it from the workbench. So you have a weighing scale. Now I am bringing a beaker onto the weighing scale. As that plus green symbol should come, only then it will sit. And then I have tared the weight to 0, and then I am bringing oxalic acid. Oxalic acid container is the source, and beaker is the recipient. Now you have to transfer. You're doing a precise transfer. So I'm typing 1.0 gram, exactly whatever you give up to 3 decimal points you can have. I'm transferring 1.0 gram of oxalic acid. You have to press pour button. I'm doing precise transfer, that is exact transfer. See, you can see 1.000 gram. That is corrected up to the 4th decimal, and oxalic acid is placed on the workbench. Now let us consider this beaker containing oxalic acid. I am also introducing another beaker for collecting water. I will be transferring 10 ml water into the beaker, into the second beaker. See, I'm pressing pour button. 10 ml. You can see 10 ml in the beaker. You can see the solution information. The beaker contains 10 ml. Now I'm going to transfer this water, 10 ml water, in through the pipette into another beaker containing oxalic acid. So for that, I have placed a pipette over the beaker and typed 10 ml, and I'm clicking on withdraw button so that the pipette will has actually withdrawn 10 ml, and I have transferred it into the first beaker containing oxalic acid solid. So when I press pour, the water in the pipette is transferred onto the beaker, and you have 10 ml oxalic acid solution. My goal is to prepare 100 ml oxalic acid solution. This is only a demo purpose. So for that, I am transferring the 10 ml oxalic acid from the beaker into the 100 ml volumetric flask. I am doing a precise transfer. On the transfer bar, I have typed 10 ml and I have clicked pour button. Now the 10 ml from the beaker has been transferred into the volumetric flask. You can see the information relating to the volume of oxalic acid solution contained in the volumetric flask by clicking on it and observing the solution information. I'm withdrawing water into the beaker. So I have typed 40 ml. I'm doing precise transfer and then clicking on pour button. You have 40 ml in the beaker. You can see the solution panel. Now I'm transferring this 40 ml into the volumetric flask. I'm again doing precise transfer. So the total solution contained in the volumetric flask can be known by clicking on the volumetric flask and observing the solution info panel on the right. I have 50 ml oxalic acid solution. After transferring the 40 ml from the beaker onto the volumetric flask, I have removed the beaker, and now I have taken Erlenmeyer flask. I'm doing precise transfer of 60 ml into the conical flask. I have typed 60 ml on the transfer bar and clicking on the pour button. 60 ml transfer has taken place. You can see the solution information on the right side panel. Now I'm bringing forward burette, and then I'll be placing the conical flask over the burette until I get a green signal. Now the conical flask is the source and burette will be the recipient. I'm transferring water into the burette. My aim is to fill the burette up to the 0 mark. Whatever is required for that I'll be doing. So still some gap is left. So I'll be transferring 1.1 ml. I'll be doing it in increments because I don't want my burette to overflow. Hence, I'm pouring or transferring in small increments like 0.05 ml. And again, one more click would transfer another 0.05. And now you can see the colorless water. You can observe the lower meniscus sitting on the 0. Now I have transferred from this to the burette and I have put aside conical flask and I'm bringing my burette onto the volumetric flask. Now I'll be transferring water into the volumetric flask. I'll be adding increments of water. First large increments and then smaller increments till the 100 ml mark is attained in the volumetric flask. You can see the solution info by clicking on the volumetric flask and observing the solution info on the right panel. So you can see the volumetric flask has 100 ml oxalic acid. You can also continue to do the titration, but still the application needs a little updation. But I believe students will feel happy to use this interface for learning practicals, especially with regard to physical chemistry titrations. For further learning, please visit the below links: spoken-tutorial.org and forums.spoken-tutorial.org on IITB platform, and ChemCollective.org. It is the ChemCollective official website. Also, register on National Mission on Education for ICT. It is a platform of IITB. I request all faculty to register on the platform. I do acknowledge some of the most prominent institutions in India for promoting faculty development. Spoken Tutorial Team, FOSSI, at IITB, and NME ICT, National Mission on Education through ICT project, and also Commissionerate of Collegiate Education. Of course, ChemCollective Virtual Labs is an international organization, and I do acknowledge their efforts sincerely. Thank you very much. Do visit our college website gdcpaderu.ac.in. Thank you once again. See you. Stay home and stay safe. Thank you.